Van der Waals radius is defined as one half of the intermolecular distance of adjacent atoms belonging to nearest neighboring molecules of the same substance in solid state. It has been observed that there are some weak forces of attraction between the neutral atoms of noble gas atoms and non-polar molecules of various substances. These are known as van der Waals forces. Due to these forces of the noble gas atoms of non-polar molecules are held together, particularly in the solid state. Thus, the van der Waals radius corresponds to the closest approach of two atoms of noble gas or non-polar molecules of other substances which otherwise do not form bonds. The measurement of van der Waals radius of chlorine is shown in figure 3. Intermolecular distance between two chlorine atoms nearest neighboring molecules is 3.6 angstrom. Van der Waals radii is bigger than covalent radii. Bragg-Steller radii. Bragg and Steller's pro- proposed set of internally consistent atomic radii. These radii can be added irrespective of the bond type involved in the interaction between two atoms, give good correlations and with observed intermolecular distances. In general terms, the Bragg-Steller radii represent the radii of inner cores of electrons. Number 2. Charge on the nucleus. The attraction force between the nucleus and the electron increases when increases in nuclear charge. This is because the force of attraction is directly proportional to the product of charges on the nucleus and that on the electrons. Therefore, with the increase of nuclear charge, it becomes more difficult to remove the electron, and ionization energy is increased. Screening effect of the inner electrons. The multi-electron atoms, the outermost electrons, are shifted or screened from nucleus by inner electrons. This is known as shielding or screening effect. ZEWF total energy Z minus screening constant S, where screening constant takes into account the screening effect of the inner electrons. If the number of electrons in the ion shell is large, the screening effect will be large. As the nucleus electron force will be less. Consequently, ionization energy will increase. Thus, if other factors do not change, an increase in the number of electrons tends to decrease the ionization energy. Number 4. Penetration effect of electrons. It is well known that in the case of multi-electron atoms, the electrons in the s orbitals have maximum probability of being found near the nucleus, and its probability goes on decreasing in case of p, d, and f orbitals. In other words, s electrons are more penetrating towards the nucleus than p electrons, and the penetration power decreases in given shell. Are more stable than the other. For example,